Welcome back to Arcade. I am Super Tommy, and in this video, we're going to look at creating Pac-Man Ghost AI. So, of course, Pac-Man is a very popular game that you've probably played. There's this Google Doodle Pac-Man here, made with Namco Bandai. And the objective of the game is just to collect the dots before the ghosts kill you, and you run out of lives. So the ghosts are these guys. If you're not familiar with the Pac-Man ghosts, which you probably are, there's the red one, the blue one, the pink one, and the orange one. So now all these ghosts have different AIs. And in this set of videos, we're going to look into implementing each of the different ghost AIs in a Pac-Man game in Phaser 3. So we're going to use this article and a video that goes over how this actually works. So we'll link this article in the description below, but each of the ghosts has a different AI behavior, and working together, they sort of like trap Pac-Man and make the game fun. So this article has the information we need, but if you want to watch something, this is a great video from Retro Game Mechanics Explained. It's a great channel, and this video is a good one. It's about 20 minutes long, explaining how the Pac-Man AI work, or how they each work. So let me shrink myself here. So we have a project set up in Phaser. npm run start here. And what we're going to do is implement the ghost and then each of the ghost AIs in a way that lets us switch them out easily. So let's go to localhost 8000. So here you can see we have this implemented, or we're going to do this again. And you see these little X's here, and that's basically showing you the targets that the ghosts are chasing. So the AIs, so there's no death here. The AIs look for a target and then move towards that target in a specific way. So you see you've got in this demo here, the red, the pink, the blue, and the various color X's that just describe where the ghost is targeting based on where Pac-Man is. So this is how the game is set up. If you want to follow along exactly using the project that we're using, the project template at least, it is in the GitHub Arcade. And this game is in TypeScript. So if you go to the Phaser 3 TypeScript parcel template, you can use this project template to start your own Pac-Man game and then implement these ghost AIs. So we're not going to cover creating this Pac-Man movement or this board, although we did make this board in tiled. So we simply use this tiled. It's a program that lets you make tile maps. So we set this board here, laid out, and then we import it into Phaser. So let's make this a little smaller so that we can get started here. All right, let's bring up the developer tools. Go to the console. All right, so everything is good here. So we have a ghost class array that we've already made for just to show you this demo, right? So that this works, and we've got like a game to build these ghosts in. We're going to focus only on the ghost and the ghost AI in this video. So let's make a new file. We're going to call this new ghost. New ghost. And we'll import Phaser from Phaser. And we're going to call this is a class. So we're doing TypeScript here, new ghost, and we're making a new class that will extend phaser.gameObjects.container. So we're using a container so that we can put different images together as one unit. So these ghosts, so you could do these ghosts as sprite sheets, but we've decided instead to break them up into, I think, 4 pieces. So we have a texture here. This is our game atlas. So here, this is Pac-Man and the dot. And then this is the ghost. So the ghost is made up of 2 bodies, and they sort of flip back and forth. That's how you see the little legs moving. And then eyes, like an eye, the white eyes here. And then the pupil, that's the little dot right there. Pupil. Oh, I got too far with the zooming. Okay, that's the pupil, and we're gonna composite them together with a container. Now, this may not be the most efficient. You could just as well make make. Let's see, how many would that be? Left eye, down eye, right eye, up eye. So that's 4, and then 2 states. So I guess six or 8. I don't know. There's some math there. When you actually go do it, you could do it that way too. And you would have a sprite sheet of, I guess, no, yeah, eight ghosts, 8, no, maybe 6, but whatever. Each go, you would need the body plus the eyes moving around. We did it this way so that we can just composite them together. So let's go here. So this is a container, and we know the container wants a scene, an X, a Y, and some children, but we definitely won't have any, so we don't need to care about that. So the scene is a phaser scene. X is a number, Y is a number. So this is a container. So in the container, we're going to composite these pieces together, the ones that we just showed you. There's the ghost body, which is going to be an animation itself, right? Because it flips back and forth between one state and another state, which we have in ghost anims. So in our other videos, you've seen us make animations, but it is very simply like this. We're creating a ghost body idle, which is how it is all the time. It just goes between 2 different pictures, the ghost body pictures, and at a frame rate of 5, and it repeats forever. So we're going to do that first because that is what the main body of the ghost is. We're going to go to new ghost. Well, you'll see that we actually did the same thing here, right? This is also a container, and it's got these things together that create this ghost. Oops. Okay, so let's say body, ghost body. Yeah, I don't want to use body just because when we add physics to this, the arcade physics adds a body property to this container, so that's just gonna confuse it. So let's call it ghost body. So scene.add.sprite. So it's a sprite because the ghost body does animate. So we'll need to make it a sprite for it to animate. Okay. So sprite, and we're gonna just say put it at 0, 0 of the container, and then the texture is, let's see. So our texture we loaded. Did we load it here? No, we loaded in our preloader. We called it the game atlas. So this game JSON that we showed, this game PNG that we showed is key to game atlas. So new ghost game atlas. Okay, now ghost body dot play and ghost body idle. Okay, so we can do this because in our game scene, we've imported this create ghost anims up here, right? Which is this code here that we saw before. And then we called that create ghost anims here. So with this create ghosts method, we're not going to call this. Okay, so no more ghosts. So for simplicity, we're going to just put this in create. You may want to create your own method to put the ghost in, but we're just going to do it like this for now. So let's just put our ghost up there. New ghost. So now this was auto imported by VS Code up here. And just in case you're using a project without the tilde that references the root source folder, you can just, the way we have it, we're a relative path going back up to the previous folder and then into the game folder. That's where our new ghost file is, right here. Okay, so new ghost. It needs the scene. It needs a position. Let's see. Let's put it up top here, which I've already pre-calculated, but you can just basically look. I think it's 256, 256. Our tiles are 32 by 32, and then you can just basically count and do some math and figure out where you want it. You can also use tiled to place them as an object layer and then read that in when you create your map and then put in the right ghost in the right place. Okay, so we have this ghost here. So this dot add dot existing, just add this ghost, see what we got. Nothing, and no errors. Oh yes. So if I'm not mistaken, let's move Pac-Man up. I forgot a step. Yep, you see there's a ghost up here, right here. So containers, you have to add your created sprites to the container explicitly, unless you're doing like new. But since we did scene.add, it's adding it to the scene. So instead, we're going to do this dot add the ghost body. So we're taking it away from the scene display list and adding it to the container display list. There we go. Oh, so 256 by 256. Yes, okay. Which is probably over here. So the container, so let's see. We can do, I think, or we may have to actually, right. Okay, so we don't want to do that. So let's just do 16 by 16 because we know our tile is 32 by 32. Okay. Now there's that guy. It's in the right spot in the world. And it's animating. So it's animating and it's white. So we made our ghost assets white because you can then tint them any color you want if it's white. If you made it a gray, it would be a little bit darker. If you made it black, you couldn't go tint it at all. And different other colors would just mess up your tinting. So if you want to tint things, you want to keep them white. We will do tinting in this class as well. Okay, so now we have this body idle. So now we have the ghost body and we have the pupil, the eyes, and then the pupils. So let's make some eyes. Let's call this eyes scene.add.image. So the eyes won't need to animate. They're just like a picture. So this is like the whites of the eyes. So we don't need to worry about that too much. So let's just say this game atlas. And let's see, what did we actually call it? So in an atlas, we used texture packer for this. And so this is called Ghost Eyes. So when you load the atlas, you can reference the frames by the key that they are inside this JSON file. Right there. Okay, so that's eyes. And then this dot add eyes. So just to help us see where these eyes are, what should we do? Okay, let's just add a tint. Let's just tint this ghost body right here. Ghost body dot set tint, and we're just going to do a red, which is FF000, I think. Okay, it's red, and there's the eyes. So you can adjust the positioning of the eye. That may be too low. It looks like a very sad ghost. Let's make it 12. Yeah, that's better. There are the eyes. So now let's do pupil. So this is left pupil. So our pupil is just one dot. So do left pupil, scene.add, another image. Doesn't need to animate, just use image. Let's see, let's go 8 by 8. And then game atlas. And then this is pupil to see what the name of the frame is. Like this. Ghost pupil PNG. New ghost. Okay, again, we need to now add the left pupil. Angle. Man, this autocomplete. Yes, pupil should be black. Dot set tint. So black is the absence of color. I think, yes, and white, yes, there we go. And white is all the colors. Okay, so it's too much. That may be right on the Y. Let's say 12. Okay. Let's go 9. Okay, so let's just say that's the middle. Now let's do the right pupil. So you see there would be some benefits of doing this in like Photoshop or something, or and then creating every frame and exporting it, which you could do, like we mentioned before, but it would also be, you would have more bigger PNGs to download since you have more frames, which could be fine. I mean, these are fairly small. It might not even matter. But we just had it this way. We just had the assets the place we left it as is. There we go. Look at this guy. Okay, so now we have the pupils, the eyes, and the ghost is set up. It's composited together using a phaser container. And let's see now. So now we want to be able to tint this ghost the various different colors and to move its pupils. So you see in Pac-Man that the ghost eyes will move. Basically, if it's going right, the eyes look right. If it's going left, the eyes look left, up, down, same thing. So we're going to do that too. And we'll just show you this feature of TypeScript using interfaces, which is a feature of other languages that are strongly typed. You would get an interface. C# has this, Java has this, C++ has this. Many languages has this, their interfaces. And when they don't, JavaScript doesn't, duck typing is another method you can go, which basically, if it has all the properties and methods you need, then it is acceptable to use. You can look up duck typing if you want more information on that. But this is the interface for Ghost. And so we'll need all of these methods and this property to adhere to the iGhost interface. And you can see that it has a make red, make teal, make pink, make orange. I'll probably just do that. Then it's got a set AI, which is going to be the state pattern that we will go over probably in the next video after we create this ghost. And then this look. So this look is going to handle where it's going to look at. So let's implement our ghost class to adhere to this interface. And so we'll just copy this for ease. There's a current direction. Okay, let's go back to our new ghost. What we want to do is here up here when you declare the class, it extends container. Then you want to implement iGhost. So now, why would you want to use interface at all? It's just a matter of programming against interface opposed to the actual ghost implementation. So now VS Code is going to tell you that it's missing these methods that it should implement. So I'll just add this real fast. So this needs to return a ghost. So return this. And we're not going to bother setting that, but we do need to import. So we have a folder called Ghost AI that has this other interface, this iGhost AI interface, right? Great. As well as the directions. I believe the directions are also in here. So what is direction? Let's just go real fast. So direction is an enum specifying left, right, up, down, and then none if it's just standing here looking at you. So it's got no direction. Otherwise, it's got the left, right, up, down direction. There's a name for those. Don't remember what they're called, but there's a name for the, I guess, north, south, east, west polar directions? I don't know. Okay. Set AI, yeah, fine. Let's just set up all this before we try to figure out what the problems are. So everything needs to return this because they all return, not everything, but all the methods that specify that it's returning an iGhost needs to return this. So we do this so that we can chain these, and Phaser does this too. You'll often see that you can do like dot set scale, dot set tint, right one right after the other. You can chain them together. That would be how you do it. You have to return the instance of itself in order to be able to chain. So now let's see. Because we have not done this, so get current direction. I'm just going to return direction none. All right, now all the red squigglies are gone. That's good. Okay. So now we can implement this as we go, as we need, effectively. But now it adheres to this interface. Okay, so make red, for example. So red is going to be, so I actually pre-picked out the Pac-Man colors ahead of time. So let's just actually go here. So I mean, you could just use the super bright red if you wanted to, but based on a picture of screenshot of Pac-Man that I've chosen from the internet, I just went in and picked out the color of what actual red is. So here we go. So let's see this. Yeah, so we want to set the ghost body to red, which means we need to actually store this as a class property. So private ghost body, which is going to be a phaser dot gameobjects dot sprite. Let's just change that, that, and that. Okay, lovely. So now we can do this dot ghost body dot set tint, and then, I guess I did not copy the color. This is just like a red with a little bit of green. Boom. Okay. There's that. So we can get rid of this tint up here. Let's see what we got. It should be white with black eyes. Okay. Head up, back up to the game here. So here's what we can do with that make red. Ghost dot make red, right? And then that will make the ghost red again. Ta-da. Okay. New ghost. So now we can implement each of these. Make teal, make pink, and make orange, which would be the same except the color changes. So we'll just quickly just copy this and then go to our pre-selected colors and change it. Let's make sure that it was teal. That was teal, pink, orange. Pink, orange. Okay. Cool. So now we're at up here, or not up, look. So this is the look. So look has only, well, I guess there's 5 different directions. There's left, right, up, down, and then none. So let's do a switch here. Switch on direction. And what we're going to do is basically adjust where the pupils are based on the direction that we want it to look in. So case direction left. So we need to modify the pupils here. The pupils. We don't actually, probably don't need these braces. We're not going to create any new variables. But we will need to save our pupils as class properties like we did for Ghost Lights. We're going to adjust them after the constructor. So left pupil, which is a phaser.gameobjects.image, and then private right pupil, which is a phaser.gameobjects.image as well. All right, so let's go over here. This, and then this. So because our pupils are white instead of black, if you wanted to, if you're so inspired, you could always make their eyes orange or something, right? Maybe it's like a Halloween Pac-Man, and you can make their eyes a different color instead of just black. Okay, let's see. So we know, well, let's just say case direction none. That one's easiest because we already did it. None is whatever it is right now, which is 912 and 2212. Okay, this dot left pupil left dot, can I do set position? Yes, XY. I forgot what I said. 912, 2212. Okay. 912. This dot right pupil set position 2212. Okay. So then left, let's just think here. Left. What would left be? So left, we want to look to the left, so let's just subtract 3. Maybe 2. 7. Oh no. This should be 9. Left is down here. So 720. And then let's just test this dot look direction dot left. So look left. Ah, there we go. That's pretty good. Okay, so now let's do right. direction right, break. So 9 plus 2, 11, 24. And let's see, we'll just test this. Dot right. Good. It's good. Okay, so now we got to do the same for up and down. So case direction dot up, break, case direction dot down, break. So instead of a switch, you could use a series of if-else if you would like, but switch does make it a little nicer looking. Okay, so 22. Okay, now we're doing up, right? So up, so this probably should be back to 9 on the X for the left guy, and 22, 9, 22. So up, let's also subtract 10, or 2. Let's see. Subtract 2 pixels, move the eyeballs up. I guess it could do that. It looks sort of sad, but let's just give it 1 more pixel so that there's no white above it. Maybe it looks even sadder. Huh, I don't know. Let's go with that one. So that was 12 minus 3, so we plus 3. Go the other direction. Down. All right. Let's say that's good. You can always adjust these to your heart's content. Okay, so now we have a ghost that can look in the various directions, and we will use that when it moves. So we can do that. Let's see. We're not going to do this ScatterAI in this video, but we will implement the basic ghost movement, which is how. So this is how it works. So when the ghost reaches a tile, like right here, when it's at the middle of a tile, and it can decide where it should go next. So in this case, it can go. Let's say it was going left. Let's say it started here and it's going left, and so it can go either up or more left, but it can't go down, and it cannot go backwards. That's just the rules of Pac-Man. The ghosts will never turn around unless they change from chase state to frightened state, or frightened state back to chase state. There's more information in these articles and in this video about that. So it has 2 options. It's going to go up and or left in this case. Now, if the ghost is, let's say, down here, then it can go, it's been going down. It can either go right, or it can go down, but it can't go left, and it can't go back up. So it cannot turn around and go the other way unless it changes state. And up is chosen first if everything is equal. And also this is how it chooses. It chooses based on the closest distance to the target. And in Blinky's case, this is the red ghost, its target is always Pac-Man. And when it's in scatter mode, so Pac-Man has scatter mode, chase mode, frightened mode, and it goes between those 3. And in scatter mode, Blinky, I believe, picks the top right or the top left corner. So let's implement the simplest, which is just going to the top. Let's go to the top left corner, so 0, 0. So let's implement that. And before we do that, we do need to give it some physics, actually. Let's go down here. So the way we set up this game, and you don't have to do it this way, but we used arcade physics so that each one of these tiles here is a wall that you can't move, that you can't cross. So we use physics for that. So let's just give this ghost a physics body. So we do scene.physics.add.existing this. And to show you the body, let's turn on debug to true. He is huge. And then this dot body dot, so let's just do this for type information. Now VS Code is not giving it to us because This could be a static and or a non-static or a dynamic body. So arcade.body. Okay. So we're actually going to make our ghost. So this is calculated based on all the items that we've put in here, I think. But it doesn't matter to us. We know our tile is 32 by 32, and that's how much room he's basically got. And we're going to use a circle collision, a circle collider, basically, to determine how it collides. So the radius will be 16, no offset. So there we go. There's a purple box around the ghost. Can't see it against red, but we'll leave the things here. Like you see, these dots all have physics as well. So there we go. So that when it moves, it's not going to just move past wall. Okay. Although you may not even need physics for the ghost, now that I think about it, but we'll just leave it. All right, so let's implement this basic movement. We're going to do it in pre-update. So pre-update is not a method that a container generally has, because Phaser by default does not add containers to the update list. I'm pretty sure we can check the code for that. But we've added it here. And in fact, let me just quickly comment this out. You'll see help from VS Code. Only our interface has it, I think, and that it doesn't, the container class itself doesn't. So I can just prove it. Let's go over here. Does this prove it? It may actually not. I just take my word for it. There is no pre-update on a container, but we can add it because we will add our container to the update list. Okay, so in the update, we're going to implement the logic for deciding how to go. So in our directions, so we have top. Okay, I didn't finish going over the ordered picks. So when it's at this tile, when it gets to a tile that I can pick where to go, it's going to, based on the tile in the direction that it can go, so up, it's going to take the distance from here to whatever target it is. So we're going to go with scatter. So 0, 0 up here. So distance from this point to that point, and distance from this point to that point. And then it's going to pick the shortest one and choose that. If they're equal distance, it's going to pick the top one first, and then the left one, then down, then right. That's just the AI of Pac-Man. And I believe I've already set this up here. So this is get ordered directions, which is up, left, down, and right. So very cool. So we have this method to help us, or not method, this function to help us get the right directions. And we added this filter here, so we know we can't go backwards. So we can just filter out the backwards direction, in which we have this helper function. Get opposite direction based on the current direction you're going. Give me, based on the direction I'm passing here, give me the opposite direction. If you're going left, the opposite is right. If you're going up, the opposite is down, and all the other combinations that could be. So here. All right, so we know, so this is Tx is going to be target X, Ty is going to be target Y. So for this example, we're going to hard code it to the top left of the screen. And let's see, let's get the directions. Directions is going to be get ordered directions. And we will filter by the current direction, which we have here, right? But currently it says direction none. So let's just do private current direction, and we'll save this. We'll change this each time we pick a new direction. So let's do that. We don't want anyone on the outside to change it, so we have a property for getting it, and then a private property for us to use inside the class that others can't touch from the outside. So filter. So let's see if this is the method. So we only want the direction not equal to, And then let's see, const, this is our backwards direction. Let's see, which is get opposite direction. This dot current direction, backwards direction. So we're going to get all the directions ordered except for our backwards direction. So we're filtering out from the 4 possible directions the backwards direction. Okay, so now we're going to have to go through each tile at the possible directions that we can do, that we can go, and check if we can actually go there. So let's go through a for loop here. Directions. Okay, so let's see. Let's do a switch. Directions I. So in the case, do I need a switch actually? No. Not. Okay, so I'll just say directions I. So let's just say this is up. So we want to know what the position is of up. And so we also have another helper method here that gets, so position in direction, I called it, maybe a better name for this. But given where you are now and the direction you want to go, it's going to return to you the position of that tile, of that tile's spots, basically. So we know tile size in our case is 32, right? You see right here, 32. And if direction is up, it's going to be whatever x you're at, and then the y is going to be y minus your tile size. So this will give us the direction. So we're standing here, it gives us this position if it's up. If we're standing here and it's left, it gives us this position. And so we're going to use that. Let's import that. Import from utils. No, utils. Where's my utils? Up one. No. That's in Ghost AI. Okay. Utils position in direction. Position in direction, check. Okay. So we want, so let's position in direction. Let's just store our current direction. This dot, let's use, we're going to use the, it doesn't matter. So this dot x, this dot y. Okay. X, y. Okay. So we're only going to want to do this when you're actually at this position in the tile. So let's just do that first. So we don't want to always be picking direction. We only want to pick direction when we get to the middle or close to the middle of an actual tile position. And so we do that. I'm going to call this gx for grid x, let's say. So we know tile size. I'll import that for me. Thank you. Math.floor. So we're doing floor since the ghost could be at, let's say, if it was at 256 here, it's at 257. So we divide by tile size by 32. That's going to give us a whole number. Well, not a whole number. We divide it a number with a fraction because we're at 257, let's say. Divide by 32, it's like, I don't know, 8 point something, or 6 point, something like that. We floor it to get only the integer number. And then we multiply the thing again by tile size so that we get the grid position that it's supposed to be on. And then same thing here, because we do this for y. Okay, great. Now, let's see, if we only want to do this if the x minus gx, let's say, is less than, well, if it's greater than 3, we're going to return, or So it has to be both X and Y near the center of where it should be a tile. Greater than 3, so return. Otherwise, we can do it, and then you can choose direction. Now this is not totally perfect yet, but we'll come back here and make it better. But for now, let's go with that. This is the target, this is position. So let's do position GX, GY. That's the middle of the tile that we're supposed to be at. And then the direction that we want to test against. So this should give us, great, an X and a Y to check the distance to target. So phaser has .math.distance.between. So we want to know distance between our target and the next, or the position we're testing against. And so here, let best direction, it's going to be direction.none, and then let best direction distance. So we're using a algorithm to determine the minimum in this case. We want the minimum distance. We'll just do -1. If best direction equal to direction.none, then we know that best direction should be whatever the direction is already. And you can hear I'm getting a lot of messages. And best direction distance is going to be whatever distance we just calculated. And then we can continue. Okay. So that's in the case where we have none set already. Now, if we already had one set, like we already did this, and I is something else, we can do if direction is less than the best direction distance we already have. If the distance, if D, distance, let's just use that. It's more readable. So if the distance that we just calculated is even smaller than the best distance, let's change best distance to that and change best direction to the current direction with the smaller distance. And there we go. And then once that is done, best direction is the direction we should go in. Okay, so that would mean now we can do the switch on best direction. And then we will want to set velocity. So we're going to set velocity to move our guy around. So let's go up here, get the body, this dot body as phaser.physics.arcade.body. And let's just, while we have body already, let's just use the body position. It shouldn't matter. I do prefer to use the physics body's position if we're going to have it anyway. I feel it's more accurate in some ways. That's when you're dealing with this, because that's the physics does control where it's going to be, so no reason not to use the body's position. So case direction dot left. So if we're going left, body dot velocity dot x is going to be let's say speed. Speed is 100. So left is minus speed, and then dot y is nothing, brick. So case direction right, we're going right. It'll be similar to this, except it's going to be positive speed. Okay. And then case direction dot up, no left or right, and minus speed on the y, and then case direction dot down. It is going to be also nothing on the x, and then just 100 positive speed. And if it's direction none, don't do anything. There we go. Okay. Yes, so it's Okay, we're not checking any walls. That's usually here. We're doing no wall checks. So we need to check that the board, that there's no tiles in here. So in this constructor, let's pass in the board. So phaser.tilemaps. What am I looking for? The dynamic tile layer. Okay, and then let's save that. So board phaser.tilemaps.dynamic tile layer. And then this.board board. And there should be an error in game here because we're not passing in the board layer, which is this.board layer. Right, so just go up here, I'll show you board layer. So we create a dynamic layer from our tiled tile set, and which is named board in our tiled app. To show you here, board. This is these walls right here. Named board. Create a dynamic layer out of that, and we're tinting it blue. That's how we get blue here, similar to the concept of the ghost body. They're like a grayish white. So that's board layer. Back to our ghost. Okay, so now direction here. Okay, before we even calculate distance, we're going to check if this dot board dot get tile at world xy, right? So if there is a tile at the position we're going to go in, don't go, continue. Now let's see what our ghost does. Yeah, error. This dot board is undefined. Right. This if, so if there is no board yet, don't do this. Board layer, not save this. There's a ghost. All right, so now the ghost is doing the right thing. It should come back around, but it got stuck because, as I said before, we didn't actually do it. Yeah. So what can happen here basically is, let's go back to our ghost, new ghost. It could be within this 3-pixel space for a while, and choose again, have to choose again, which is why, so it could be choosing twice, like, so it's going down, then it's choosing again, and it's picking another direction, and it happens to be the backwards direction. So what we're going to do, we have this current position, current direction, which is going to be this direction. That doesn't solve this problem, but we should have saved that anyway. Well, it may. No, I guess that was a slightly different issue, but there is still this possibility, let's fix it now, that this is true for 2 frames, effectively. So it's going to choose twice. It'll more likely come when it gets to one of these, right? It gets here, it's going left, it picks going down, and then it picks again, and then it's going to go right, let's say. Would that happen? Maybe not in the exact order, but like maybe over here. But either way, it's a possibility that you could be in this section twice. It's not often that will happen, but it could happen. And so what you can do is save the GXGY here as the last tile that it calculated a direction to go in from. And then don't do it if the GXGY is the same, and then you change it each time you actually pick a new direction. Since we have no problem, we'll just leave this alone. Okay, so that's the ghost moving, and it's moving, it's picking this spot, so that's why it's going here forever. It's nothing to do with Pac-Man right now. It's just going to do that. So if we change txty to be instead, let me just do board dot width. So it's going to be up here, right? It should go all the way up there. Oh, okay. So here's the problem. So we saw that it went backwards. So we have a problem. We'll add this fix. This video is getting long, but we'll add this fix anyway. All right, so that's as we were saying, what we wanted to do is last that's the last tile position. And we're going to do a phaser dot is it math dot point? Math.geom dot point. So you can just do this. I'm going to create this point class. Do that. And then come down here. So it's once it picks a direction, let's do this dot last tile position dot x gx, this dot last tile position dot y gy. Okay, and then if this dot last tile position dot x equals to gx and this dot last dot y equals to gy, don't do anything. Let's go back. Boop. So there we go. Didn't pick more than once, and this is basically the scatter logic, right, that we have this ghost doing right now. And it's going to circle around there, so we'll do another test to show you. So let's go with this .board.height. So that's going to be at the bottom right corner down here. We just watch this guy go. And it's going to circle around this, this area forever. Cool. And then one more time, bottom left corner, scatter. These are actual scatter points for the ghosts. I think Clyde is usually one down here. And there we go. And they'll just stay there forever, basically, when it's in scatter mode. From wherever it is going to go down to its scatter position. All right, so this has been a pretty long video that was just creating the ghost and creating the basic ScatterAI inside this ghost class. So we have this setAI method, and we are going to, in the next video, implement a state pattern so that we can give the ghost any number of AIs, including the scatter, and then Blinky has this chase AI, Pinky has the chase AI, the different type of chase AI. There's 4 of them, and scatter. So we're going to, in the next video, show you scatter and taking out the scatter movement logic, move it into a state, and then pass that state into the ghost.